Welcome to my video lecture series in Game Concept and Production. This is Professor Janus Raymond Tan from the College of Computing and Engineering. For this video lecture, we will cover the topics about mechanics and dynamics. Throughout this video, we will cover the topics about the process of design and MDA framework, mechanics, dynamics, aesthetics introduction, the process of play, game mechanic versus gameplay, mechanics, dynamics and complexity, feedback loops, and emergence. Until this point, we have made games and game rules, but at no point have we examined what makes a good rule from a bad one, nor have we really examined the different kinds of rules that form a game designer's palette, nor have we talked about the relationship between the game rules and the player experience. Mechanics, dynamics, aesthetics, or MDA is a formal approach to better understand games. It is considered to be the bridge between the game development and the game design. It is helpful to study mechanics, dynamics, aesthetics because we can break up our game into three core categories and work in each category until we have the perfect game. MDA framework by LeBlanc, Honeck, and Zabek define a game in terms of its mechanics, dynamics, and aesthetics. Mechanics are synonym for the rules of the game. It answers the questions such as how is the game set up, what action players can take, and what effects do those actions have on the game state, when does the game end, and how is a resolution determined. These are the constraints under which the game operates. They are defined by mechanics. Dynamics describe the play of the game when the rules are set in motion. It answers the questions such as what strategies emerge from the rules, how do players interact with one another. In other words, dynamics refers the underlying change as a player plays the game. Aesthetics in MDA sense is the player experience of the game. It answers the questions such as is the game fun? Is play frustrating, boring, or interesting? Is the play emotionally or intellectually engaging? Aesthetics do not refer to the visual elements of the game, but rather the player experience of the game, the effect that the dynamics have on the players themselves. Before the MDA framework was written, the terms mechanics and dynamics were already in common use among designers. The term aesthetics, in this sense, had not, but has gained more use in recent years. Game designer only creates the mechanics directly. The dynamics emerge from the mechanics, and the aesthetics arise out of dynamics. The game designer may want to design the player experience, or at least maybe the ultimate goal the designer has in mind. But as designers, we are stuck building the rules of the game and hoping that the desired experience emerges from our rules. For the MDA introduction, the developer creates games and players consumes the game as shown in the given figure. One of the main concepts to understand is that the developer creates games and players consumes the game. This leads to a spectacular or specular approach, which is the game development approach. The play phase from the perspective of the player can be broken into three simple phases. The player understands the rules, interacts with the system, and starts to have fun as shown in the given figure. But from the designer's perspective, these lead into three counterparts, which is the M, D, and A. M for mechanics, which describes the hidden part of the game. The mechanics are the rules and interactions described with algorithms and data structures. Dynamics is the part of the mechanics that player can actually see. It describes what the outcome is when the player presses a button or in general sends an input to the game. Aesthetics describes the desirable emotional responses evoked in the player when the player interacts with the game system. If the player and the developer's perspective in the MDA framework will end in this situation, the player starts his experience by seeing the aesthetic part of the game. The player can also interact with the dynamics but never with the mechanics. Due to the fact that this person is making the game, The designer will start from the mechanics and then go up to the dynamic aspect of the game. When working with games, it is very helpful to consider both the designer and player perspectives and try to deliver the best experience for the player. It is also helpful to observe how even small changes in one layer can cascade into others and impact all the game. For the process of play, designers start with the mechanics and follow them as they grow outward into the aesthetics. You can think of a game as a sphere, with the mechanics at the core, the dynamics surrounding them, and the aesthetics on the surface, each layer growing out of one inside it. One thing the authors of MDA point out is that this is not how games are experienced from the player's point of view. A player sees the surface first, the aesthetics. They may be aware of the mechanics and dynamics, but the thing that really makes an immediate impression and that is most easily understood is the aesthetics. This is why, even with absolutely no knowledge or training in game design, anyone can play a game and tell you whether or not they are having a good time. They may not be able to articulate why they are having a good time or what makes the game good or bad, but anyone can tell you right away how a game makes them feel. If a player spends enough time with the game, they may learn to appreciate the dynamics of the game and how their experience arises from them. They may realize that they do or don't like a game because of the specific kinds of interaction they are having with the game and or the other players. And if a player spends even more time in that game, they may eventually have a strong enough grasp of the mechanics to see how the dynamics are emerging from them. If a game is a sphere that is designed from the inside out, just like in the figure, it is played from the outside in. And this is one of the key points of the MDA. The designer creates the mechanics and everything flows outward from that. The player experiences the aesthetics and then their experience flow inward. As designers, we must be aware both of these ways of interacting with the game. Otherwise, we are liable to create games that are fun for designers but not for players. Ever wondered what's the difference between game mechanic and gameplay? Here are some examples to help you understand. In Counter-Strike game, your guns as weapons are game mechanics, while the gameplay will be, with limited HP, you either die fast or live long enough. In Call of Duty game, this time, your guns and headset are considered game mechanics, while the gameplay will be something that a player will realize that because words hurt more than bullets or trash talking during the game. In the Division game, it says that the weapons deals 190k damage per second and that's the game mechanic of the game, while the gameplay will be the player realizes that the weapon doesn't matter because all players are tank, or in simple means, a player has a strong defense. Adding additional mechanics, new systems, additional game objects, and new ways for objects to interact with one another or for players to interact with the game will lead to a greater complexity in the dynamics of the game. For example, compare chess and checkers. Chess has 6 pieces instead of 2 in checkers, and the greater the number of actions that each piece can take, so it ends up having more strategic depth. Is more complexity good or bad? It depends. Tetris is a very simple but very successful game. Advanced Squad Leader is an incredibly complex game but still can be considered successful for what it is. Some games are so simple that they are not fun beyond a certain age, like tic-tac-toe. Other games are too complex for their own good and would be better if their systems were a bit more simplified and streamlined. Do more complex mechanics always lead to more complex dynamics? No, there are some cases where very simple mechanics create extreme complexity, and there are other cases where the mechanics are extremely complicated, but the dynamics are simple. The best way to gauge complexity, as you may have guessed, is to play the game. Feedback loops. This is a game system where the output is defined by the player and is then used as the input for another system or even the latest loop of an existing system. Some systems look at positive play and give that player more chances for success. Other systems may give players who are struggling a boost to even out the odds. Properly managed feedback loops make for good games while poor feedback loops can ruin an experience. So some examples are, in Modern Warfare 2 game, if you are winning, a feedback loop will be you are rewarded with a tactical nuke or a strong weapon which leads you to more winning. And this is an example of a positive feedback loop, something that will benefit the player. Another example is the Mario Kart game. If you are losing, a feedback loop will be you are rewarded by a blue shell which can be used to ruin your friend's victory. This time, a negative feedback loop is portrayed since it has negative effects to other game systems. The next one is XCOM 2 game. There is also the possibility to encounter unbalanced positive feedback loop. In the case of this game, if you are winning and your soldiers survive long enough, they level up until they became unstoppable. And that is unbalanced positive feedback loop. Positive feedback loop is said to be a reinforcing relationship. Something happens that causes the same thing to happen again, which causes it to happen yet again, getting stronger in each iteration, like a snowball that starts out small at the top of the hill and gets larger and faster as it rolls and collects more snow. Example is the NES game, The Guardian Legend. Once you beat the game, you get access to the special extra gameplay mode. In this mode, you got rewarded with power-ups, and at the end of each level based on your score, the higher your score, the more power-ups you got for the next level. If you get a high score, it gives you more power-ups, which make it easier to get an even higher score in the next level, which gives you an even more power-ups and so on. Notice that in this case, the reverse is also true. Suppose you get a low score, then you get fewer power-ups at the end of that level, which makes it harder for you to do well on the next level, which means you will probably get an even lower score, and so on until you are far behind that it is nearly impossible for you to proceed at all. The properties of positive feedback loops. There are 3 properties of positive feedback loops that the game designers should be aware of. Number 1, they tend to destabilize the game. As one player gets further and further ahead or behind, they cause the game to end faster, and they put emphasis on the early game since the effects of early game decisions are magnified over time. What about negative feedback loops? Negative feedback loops are said to be a balancing relationship. When something happens in a game, such as one player gaining an advantage over the others, a negative feedback loop makes it harder for that same thing to happen again. If one player gets in the lead, a negative feedback loop makes it easier for the opponents to catch up and harder for a winning player to extend their lead. Example is the Mario Kart racing game. As the player gets ahead of the pack, the opponents start cheating, finding better power-ups, and getting impossible bursts of speed to help them catch up. This makes it more difficult for the player to maintain or extend a lead. This particular feedback loop is sometimes referred to as rubber banding because the cars behave as if they are connected by rubber bands, pulling the leaders and losing back to the center of the pack. If the player falls behind, they will find better power-ups and the opponents will slow down to allow the player to catch up. Negative feedback loops also have 3 important properties. Number 1, they tend to stabilize the game, causing players to tend towards the center of the pack. They cause the game to take longer. they put emphasis on the late game since early game decisions are reduced in their impact over time. Now, how to eliminate feedback loops? Suppose you identify a feedback loop in your game and you want to remove it. How do you do this? There are two ways. The first is to shut off the feedback loop itself. All feedback loops, positive and negative, have three components. Number one, a sensor that monitors the game state. Number two, a comparator that decides whether to take action based on the value monitored by the sensor. Number three, an activator that modifies the game state when the comparator decides to do so. For example, in the earlier kart racing game, negative feedback loop example, the sensor is how far ahead or behind the player is. Relative to the rest of the pack, the comparator checks to see if the player is farther ahead or behind a certain threshold of value. And the activator causes the opposing cars to either speed up or slow down accordingly. If the player is too far ahead or behind, all of these may form a single mechanic. If the player is more than 300 meters ahead of all opponents, multiply everyone else's speed by 150%. In other cases, there may be 3 or more separate mechanics that cause the feedback loop, and changing any one of them will modify the nature of the loop. By being aware of the mechanics causing a feedback loop, you can disrupt the effects by either removing the sensor, changing or removing the comparator, or modifying or removing the effect of the activator. If you do not want to remove the feedback loop from the game but you do want to reduce its effects, an alternative is to add another feedback loop of the opposing type. Again, returning to the kart racing game, if you wanted to keep the rubber banding negative feedback loop, you could add a positive feedback loop to counteract it. For example, if the opposing cars get speed boosts when the player is ahead, perhaps the player can go faster as well, leading to a case where being in the lead makes the entire race go faster, but not giving an advantage or disadvantage to anyone. Or maybe the player in the lead can find better power-ups to compensate for the opponent's new speed advantage. Emergence or emergent gameplay. This game is broken. This game is unbalanced. You can beat this game by spamming it. What were they thinking? These are some of the experiences of players in a game. Emergence or emergent gameplay describes a game with simple mechanics but complex dynamics. Emergent complexity can be used to describe any system of this nature, even things that are not games. It refers to anything discovered by game players that was not explicitly planned and designed by a game's creators. In simple means, it is not always planned for. When someone says a game is broken, they are usually talking about glitches and bugs that game developers didn't catch, but that players did. This is emergent gameplay. When someone calls a game unbalanced, this is usually because a certain character or strategy is being used in a way the original creators didn't foresee. And it will also likely has to do, on some level, with emergent gameplay. When someone says you can beat a game by spamming a single move, this refers to a mechanic programmed into a game being used in a way that the creators didn't foresee. That is emergent gameplay. In summary, we can say that mechanics, dynamics, aesthetics, or MDA is a formal approach for or to better understand games. The game designer only creates the mechanics directly, the dynamics emerge from the mechanics, and the aesthetics arise out of the dynamics. In games, a game mechanic is the weapon, while gameplay is how it works with other mechanics. A feedback loop is a game system where the output is defined by the player and is then used as the input for another system or even the latest loop of an existing system. Emergent gameplay refers to anything discovered by game players that was not explicitly planned and designed by a game creator. For this lesson activity, form a 5-member group and select an existing computer or mobile game which is popular nowadays. Identify and explain the positive and negative feedback loops of the selected game. Follow the given format and attach your PDF file which contains your answers in the week 4 channel of our teams. Include the names of the members of the group. So here will be your format. We have the selected game title here. Describe the game according to its description or gameplay. Provide identified positive feedback loops and negative feedback loops. That's it for now. Thank you for watching. Hope you enjoyed this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about the overview of the game design process. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.